Hello everyone, welcome to the class. In this class, I'll discuss this numerical which came in Bangalore City exam. This problem is related to normal distribution curve. Okay, so I believe everyone are pretty clear about normal distribution curve. So basically, when we talk about normal distribution curve, it is basically a bell-shaped curve, okay, where we believe that the average or the measure of central tendency lies at the central part. Okay, and then when we talk about measure of dispersion, it will disperse from the center. And that property where the data disperse from the center that we study under measure of dispersion. And the term what we normally use to represent the measure of dispersion, although in measure of dispersion, we have lot of absolute terms, we have lot of relative terms, but generally we use one of the very frequent term that is standard deviation. So, like we believe that around 68% of data lies in the plus minus of one standard deviation. Then around 95% of data lies in the plus minus of two standard deviation. And then this curve never touches the x-axis. Always remember, and this you can just simply ignore. And then around 99.73% of data lies in the plus minus of three standard deviation. That is the normal assumption of working on the normal distribution curve. I'll not go much about theoretical part. You can study that by yourself. The probability formula under the normal distribution curve is 1 by sigma under root 2 pi e to the power minus 1 by 2 x bar minus mu by sigma whole square. So this formula also not so important, especially those people who prepare for CA foundation or they are doing BSc mathematics or BCA. There sometimes the interpretation of this formula makes some sense for them. Otherwise, for other people, they can simply just aware that there's some formula of the probability distribution curve. So a lot of mathematician, either it was Demo, either Gauss, they contributed a lot to understand this bell-shaped curve, which we call a normal distribution curve. Asymmetry in the normal distribution curve is discussed under skewness and kurtosis. Okay, so you can spend more time to know theoretical part of skewness and kurtosis. Bangalore City normally touch skewness and kurtosis when they have to ask theoretical problems. Kurtosis numerical never will come in Bangalore City. Skewness maybe they can be numerical. So you just need to remember two forms of skewness formula. One is Carl Pearson coefficient of skewness. Okay, and the other one is Boyle coefficient of skewness. You can go through them. Q1 plus Q3 minus 2 times of median divided by Q3 minus Q1 or mean minus mode divided by standard deviation. You can go through the formula. I already made significant videos discussing about skewness, the coefficient of skewness. You can go through them to understand that. Purpose of this doing this class is to focus more on this numerical. Okay, this numerical which normally the student get confused in exam. So we'll try to talk about this numerical. Okay, so this here, if you see the data, the total, the number is given as 300. So around 300 students are there in the class where the mean, so the population mean is given to us is the 68 inch. That is the population mean. That is the population mean. And the standard deviation of the data is 2 inch. That is the standard deviation. Okay, and then this much data is given. The question is that how many students have a height greater than 72 inch? Okay, so this is the question. So let me just clear the screen. So very simple question. You just need to draw the diagram. So when you draw the normal distribution curve, you can understand total area is 50% lies on left hand side, 50% lies on right hand side. So the mean is this is 68 inch. Mean is population mean is 68 inch. Standard deviation is 2 inch. The question is that how many students have a height greater than 72 inch? So 72 will lie which side? 72 will lies in the right hand side of population mean, right? So this it lies on right hand side. So you can see this. So the sample means greater than 72 inch means what area they're talking about. They're expecting you to calculate this area. They're expecting you to calculate this area, right? They are expecting you to calculate this area, right? I told you that whenever you draw the normal distribution curve, in the normal distribution curve, 50% of area will lie on left hand side, 50% of area will lie on the right hand side. Okay, and here what I want this area, right? I'm looking for this area. I'm looking for this area. The what is my objective? This area A, B, C, D. This area I'm looking for. Okay, and here what I know. Here what I know that area. I want to know this area. This M N C D. That area M N C D. That area is 0.5, right? And I can find this area. I can find this area M N A B. I can find this area. How will I find this area? Very easily. So there's a formula is given. So x bar minus mu by sigma. So with this formula, you can always find the area from the central part to the any other point in the graph. So x bar here will be 72 and mu would be 68 by sigma. Sigma is 2. This is 4 by 2 means 2. So this area, so what you do with this area, you need to find this area, the area corresponding to the two value. Okay, so what you need to do when you use this formula, you will get a mathematical value. Okay, so the mathematical value, whatever you get, you need to observe. You need to observe the z value equal to 2 in the normal distribution curve. Observe this value in the normal distribution curve. Observe this value in the normal distribution curve. So if you observe this value in the normal distribution curve, what value you'll get? You'll get that area. So the area MNAB. So the area MNAB under the normal distribution curve. Okay, that is equal to how much? This value 2. The value 2, if you see, that is 0.4772. This value is 0.4772. This value is 0.4772. So the area, so what is your area? If you are looking for the area, so the area A, B, C, D is basically 0.5 minus this area, minus the area, MNAB. Very simple. 50% area lies on left hand side, 50% area lies on right hand side. So the area ABCD, this will be 0.5 minus 0.4772. This will be 8, 9 minus 7, 2, 9 minus 7, 2. Okay, 9 minus 7, 2. And then 4 minus 4, 0. So you will get the area value equal to 0.0228. And I want the number, right? I don't want the probability or the area. What I want the number. So the number, how will you get? So that number, how many people have an average height greater than 72 inch? Total number is given to you 300, right? So this will be 300 into 0.0228. Find this value. This is 0.5 minus 0.4772. This is 0.0228. This into 300. 6.84. So you can write approximately 7. 7 is the answer for this problem. Clear, everyone? Then equal to 66 inch. If I say equal to 66, how many students have a height equal to 66 inch? Okay, so yeah, equal to, if I talk about equal to 66 inch, if you see this question number 2, equal to 66 inch. So here what I'll find the value. So the equal to 66 inch. So 66 will lie this side, right? Now what area I'm looking for? I'm looking for this area equal to 66 inch. So less than 66 inch I can find, greater than 66 inch I can find, equal to 66 inch, less than or equal to I can find. So equal to 66 inch, how will we find this value? So because if I calculate this formula called z value equal to x bar minus mu by sigma, where if I try to calculate this area, we can find the area. We cannot find the defined value. Z is equal to x bar minus mu by sigma. Okay, so how many people have a height? How many people have a height? Uh, Here less than or equal to, if I find z is equal to x minus mu by sigma. So here this is 61, right? So if I'm looking for this area, the number of people having height between 66 to 68 inch. So the number of people having height, number of people having height between 66 to 68 inch. So I can do that. So x bar minus mu by sigma. So x bar is 66 minus 68 by 2. So x bar here in this case would be 66. Mu, that mu is a population mean, that always be 68 only. So this is minus 2 by 2. This is minus 1. So ignore the sign here. So the value 1 correspond to what? So that you can see the area correspond to 1. 0.3413. This area, the area corresponding to z value equal to 1. That area is equal to, this area is equal to 0.3413. This is 0.3413. This area is 0.3413. Okay, so lesser than this is 0.5 minus. This is 0.5 minus that, and this is 0.5 plus this. Okay. So this area is 0.3413. Okay, so I can find the number, right? I can find this number. So the number total 300 people are there, right? So how many people are there? Total 300. So I can find this 300 into 0.413. 300 into 0.3413. So 300 into 0.3413, 102.3, 102, you can say around 102 people are there which have height between 66 to 68 inch. So around 102 people are there which have height between 66 to 68 inch. Here I want the number of students having height equal to 66 inch. Equal to 66 inch, how will I find? I can find the region. Are you getting me? I can find the area, and based upon the area, I can find the number by multiplying with 1000. So it's equal to 68. I can find less than 68. So less than 68 would be what? 0.5 minus 3413 into 300, or what, 300, right? Into 300 I can do. Greater than also I can find. If I find less than, so 300 minus that would be greater than. Okay, how will I find equal to 66? That is very difficult to do that. Equal to or less than, I got area. You're getting me, right? So equal to 66 inch you cannot find. So So equal to 66 inch you cannot find. Answer for this would be cannot be determined. Okay, equal to this will be it cannot be determined. Okay, so you can find either less than 66 inch, either greater than 66 inch, or either between 62 to 68 inch, or anything 66 to anything. You want this area, this and this also you can find. You can add the area. Okay, you can find a number. So you can always find a number between the two range, not equal to any range. Any doubt, anyone? Now the next part of the question is less than or equal to 60 inch. Less than or equal to 60 inch. The next part of the question is less than or equal to 60 inch. So here the population mean was 68, standard deviation is 2, and the number of the student is 300. Number of students are 300. Number of students are 300. Okay. So less than equal to 60 means what area actually I'm looking for. So I'm looking for this area A, B, C, D. So you can write this as M, N. Okay, you know this, right? 50% of area lies this side. 50% of area lies in this side. Okay, so if I'm looking for this area called if I'm looking for this area called A, B, C, D, so that will be equal to 50% minus this area. Okay, area M, N, A, B. So, so the area ABCD, because I want less than or equal to 60, right? I want this side. I think you just need to understand by using common sense. So the area ABCD, this will be 0.5 minus M and AB you can easily find by using this formula called x bar minus mu by sigma. You use that formula. So the area ABCD, so the area ABCD, this will be 0.5 minus z value correspond to x bar 60 minus mu 68 by sigma. Sigma is almost 2. So you can easily find area ABCD equal to 0.5 minus z value corresponding to 8 by 2 means 4 minus 4. So the 8, so minus 4. Let's see, is that value given or not? I don't think so. Still 3 the value is given. This value 4 if you want normal distribution table. If I try norm list function, norm list I don't think. 0.7 for example, 0.7580. 0.7580, right? So including 0.5 it is doing. Point 9999 minus 0.5. That will be 0.499968. 1.3 factor norm dist 1.3 equal to norm dist One 1.2, 0.88493, 1.2, 0.88493, 493, 0.8849. Yeah, so zero point 0.5 is added, right? Zero point 0.5 is added here, showing always right hand side. So this will be 0.499. This value will be 0.4999. Okay, so this value you don't get in table also. This value is 0.49998 whatever. So the area of ABCD, that is equal to zero point 0.5 minus this value, okay, 0.5 minus 0.4999 something if I write 1 2 3 4, this is 40000 0.400 0.404. So the number if I want, this is 300 into 0.40004. It does not make any sense. I don't know why they create question like this. This will create error and all student get confused. 0.0095. Number student cannot be 0.0095, right? It's not even one student. Number is like kind of zero only. Are you getting me right? So it would be very small area, very small area. Because if you remember, I told you standard deviation, like 99.73% of data lies in the plus minus of 3 standard deviation. Here you're getting 4 standard deviation. You can see that area value -4. If you see this normal distribution table also what I have, here the value is given till 3. Okay, so you can understand the area also what you see here. If I Google normal distribution table, till 3.9 it is given. It is, this also have not given 4 value. It is given only till 3.9. You can see 0.99999995 is minus 0.5 you have to do. Here you can see minus 0.4 times 0 then 5. Left hand side of the curve. So I really don't understand why Bangalore City is giving such kind of vague data in exam and all. It create a lot of confusion in the student mind. Between 65 and 75 inch, between 65 and 71 inch, between 65 and 71 inch. So between 65 and 71 inch. So this 68, right? This is 68. Standard deviation is 2 inch. This is 68 inch. 68, no? Population means 68 into 65 to 71. 65 to 71 if you want. So 65 to 71 if you want. I want this area, right? This area I want A, B, CD, this area I want. Okay, this area I want. You know, right? 50% of area left hand side, 50% of area right hand side. So I want this area ABCD. This area ABCD is nothing but it is a sum of area ABMN and the area MNCD. And the formula, no, what we follow, x bar minus mu by sigma. This formula always give you the z value from central point to the end. So one end. So you just need to use that formula. Okay. Do this calculation. So 65 here you just do 65 68 by 2. Value this will be 71 minus 68 divided by 2. Yeah. So the area here Z1. This is 3, no, 1.5. This area Z2 area, this is 3, 1.5. You simply, you just need to find the area, and for the number, what you do, just multiply that with 300. Just find this area, Z area, 1.5, and then multiply 2 times of that, multiply with 300 to get the number. Z value 1.5. You can see 0.5 is added. You can see 0.00. You can see 0.5. So Z value, what value I want? 1.5. 0.93319. So actually, the actual area is 0.43319. Are you getting it? 0.5 is already added in that. If you know, so you can see this. Actually, when you see the table in exam, you can either, when you ask for normal distribution table, you can see if for Z 0, if the value given is 0, means you are talking about that point area. Okay, you're talking about that point area. If it's given 0.5, actual area will be 0.5 minus that. Okay, so here like 1.5 if I want. So that is 0.4332. If you see that table, it would have been 0.9332. This is 0.332. This is 0.332. So this is 300 into 2 into 0.. The number will be 300 means 600 into 0.433. 600 into 0.4332. 259, 260. Around 260 students have. Fine. No? So I hope you understood this. So this much was there to be done for this question. I hope you people understood this. The purpose of doing this session is to make sure that any numericals which can probably come in your biology exam for this subject called statistics for management, for this topic called normal distribution, you should be in position to do them very easily. So with that faith that you have understood what all I have done in this class, time to wind up the class. Thank you everyone. God bless you. Take care.